Now we go to the subtopic 3.3 hypothesis testing. Given an economic and statistical model, hypotheses are formed about economic behavior. For a multiple linear model, the hypothesis testing is concerned on beta 2, beta 3 up to beta k, since the focus of economic model is to study the relationship between x and y. There are three types of hypothesis testing in econometrics multiple linear regression. The first one is testing the significance of the MLR model. This is to test whether variable y related to x. There are two tests can be applied here. The first one is F test and the second one is p-value approach. The second type of test that is testing the significance of a single coefficient. In this part, when we set up a multiple linear regression model, we believe variable x significant to y. To confirm this belief, we need to examine whether it is supported by the data. This test is called a test of significance for the independent variable, that is x. The test is a two-tailed test. For this case, we can use either p-value approach or t-test. The third type is testing of economic hypothesis. In this test, we want to check the effect of each variable x to y. And the test is a one-tailed test, either right-tailed test or left-tailed test. And in this test, we can use either a p-value approach or t-test. The types of hypothesis testing are summarized in this diagram. For the test of significance of multiple linear regression model, the test used is F-test, or we also can use p-value approach with the hypothesis H0 and H1 as stated here. For the test of significance for a single coefficient, the test is a two-tailed test where the H0 and H1 is given here. K here actually is referred to the kth of independent variable. And in this test, we can use either t-test or p-value. While for the test of economic hypothesis, okay, that one, under one-tailed test for a single coefficient, specifically left-tailed test and right-tailed test. The test used here either p-value or t-test, depends on the approach given. So when we look at the hypothesis stated here, either for left-tailed test or right-tailed test, the beta naught here actually is the hypothesized value. Let's look at example 3.3.1. In this example, we want to test the economic theory given for the study. That is whether the average sales revenue is linearly related to price and advertising expenditure. Okay, so the test is called testing the significance of MLR model. So this is under topic 3.3.1. To study the linear relationship between the variables in the data given, there are two approaches that we can apply that are either F-test or p-value approach. Let's say for this example, we want to go for F-test approach first. With alpha equals to 0.05. In this example, we consider the data of example 3.2. Since we use F-test approach, and F-test approach is under traditional approach, so that's why we have 5 steps here. Step 1 is to construct the hypothesis. Since we want to test the linear relationship between the variables, which is this is referred to this statement, okay, where this is the claim. Okay, this statement represent that at least one of the independent variables related to y. And since in this case we have x2 and x3, so that's why k here, that is k must be greater than or equals to 2. Okay, and then we construct hash knot. Hash knot that is beta 2 equals to 0 and beta 3 equals to 0. Note that, okay, this is actually represent for x2 and x3, since beta 2 and beta 3 actually is the parameters for independence variable of x2 and x3 respectively. Okay, so now we go to step 2. So since we want to use F-test, so we can get the F-test value from ANOVA table, okay, from the Excel output. So the F-test is given by this value, the F column. Okay, so by taking the value at 4 decimal places, so now we get F-test equals to 8.9024. Okay, so now complete step 2. So now we go step 3. Step 3, we want to establish the test criterion. Okay, so in the test criterion, we want to determine the rejection region and critical value. And for F-test, the test is always right tail test. Okay, it's always right tail test. Okay, and the value alpha here in this case is 0.05. So in general, F critical value is F alpha with the first degrees of freedom and the second degrees of freedom. The first degrees of freedom and the second degrees of freedom can be obtained from this value. This shows us no 1. That represent for the first decrease of freedom, while this value represent for no 2. This is the second decrease of freedom. So means that our critical value here, that is F 0.05 with a decrease of freedom 2 and 17. And by using statistical table, the value is equals to 3.5915. Okay. Now we go to step 4. In step 4, we want to make a decision for H0. By comparing F test and F critical value here, where F test greater than F critical value, and note that the test for F test is right tail test, so the decision is reject H0. The decision of reject H0 is also supported graphically by using F test here, that is lies. You can see that this is lies on the rejection region. So complete step 4. So now we go to step 5. In step 5, we want to draw a conclusion. Since the decision in step 4 here is reject H0, so reject H0 here, means that we accept the claim. Means that the conclusion here is at alpha 0.05, there is a statistically significant relationship between variables where sales revenue is linearly related to at least one of independent variables, either price or advertising expenditure. So now we go to example 3.3.2. In this example, we use p-value approach. With the same significance level, that is alpha equals to 0.05. Since we use p-value approach, so there are 4 steps here. Step 1 is the same as explained in example 3.3.1. So we go to step 2. In step 2, we want to get the p-value, and we can get the p-value from ANOVA table by focusing on this part. So the p-value can be obtained from this part. So by taking the value at 4 decimal places, so the p-value now is 0.0023. So now we go to step 3. By using the standard rule of p-value, and since p-value here is less than alpha, so the decision is reject H0. So the last step here, that is draw a conclusion. And the conclusion here, of course, is the same as given in example 3.3.1.